Hi, this video introduces the computer program called Seqsee. The task that the program does is the following. It is given as input some integer sequence, such as the one you currently see on the screen. Seqsee's job is to understand the sequence. En route to understanding it, it may ask questions such as the following. Here is the question, and the person interacting with the program can either say yes or no. This is the final stage of Seqsee understanding the sequence. Seqsee has understood the structure, described it in words, and extended it. A few things are worth noting about why this project is being attempted. The goal is not the best sequence understander, but rather an exploration of human cognition. The sequence domain provides an excellent playground to explore many fascinating ideas, and we will now look at some of these. Look at this simple sequence on the screen. It is of course made up of these blocks where each block has 1 at the beginning and the second term is increasing as we go forward. Look at this other sequence now. It has exactly the same structure, but subjects in an experiment took 6 times as long to understand it as for the other sequence. Why this disparity? To answer that question, let us look at an intermediate stage in solving this. Here, the initial 111 group has been seen. This group is attractive and sensible looking, and yet it is distracting. Until this group is split apart and seen as consisting of an initial 1-1 and a 1-2, the sequence cannot really be understood completely. This is a very common theme seen again and again. Whenever a sequence contains a chunk that can be seen in a way that's not consistent with the global interpretation of the sequence, a garden path fragment, so to speak, Seqsee takes much longer, as do people. Let's now turn to a second type of cognitively interesting phenomenon in this domain. This is a much harder sequence than those encountered so far. If you wish, you may pause the video at this time and try to see what this sequence is all about. I will let the video continue and see and show the final structure. Here is the final structure as understood by Seqsee. Let's see what's going on here. This is the final structure seen by Seqsee at the end of the run. Notice that this last oval is a group consisting of other groups. And so is this, although it's a little shorter. And so is this, although it is even shorter. And so also must be this. This one is a degenerate case which consists of groups where the only group is a single one. That is a very bizarre and strange way of describing a one, yet it is necessary for this sequence to be completely understood. An important question to ask is how Seqsee arrived at this complex description for this group. It absolutely makes no sense for Seqsee to ask itself questions such that, is this single element really a group of group for some other one like this one or for a 3 and so forth. So Seqsee only asked that question of itself when there was a good reason for it to do so based on other sequences here. A brute force approach would find this hard to do. This idea of trying something out only when there is reason to believe that it might succeed is closely tied to human intuition. The following sequence, although very different, exemplifies the same idea. The viewer should momentarily pause this video if needed in order to understand this sequence. This sequence is clearly made up of blocks of size 3. The 3-ness of the sequence is somehow very apparent to us even without the ovals. In reaching the conclusion that size 3 ovals are involved here, we probably did not even try to see if ovals of size 2 would work, like whether 1, 7, 19, 1, 8, 20, 1, 9. Would this grouping work is a question that we probably did not even ask ourselves. And nor should Seqsee. I will now show one final example demonstrating the cognitive richness of this domain. There are many ways of looking at this sequence. One possibility is to consider this as consisting of 1, 1, 2, 3, 1, 2, 2, 3, 4, 1, 2, 3, 3, 4, 5, and so on. However, there is a second way that people, when they arrive at, find very compelling. In this second way of looking at things, this is really just a 1, 2, 3 with something funny going on here. This is really just a 1, 2, 3, 4 with something doubled here. And this is really just a 1, 2, 3, 4, 5 with something doubled here. And so the sequence is 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. But what is being doubled is actually shifting. Let's see how Seqsee fares on this sequence. Here is what Seqsee has finally seen the sequence as. It's seen the 1, 1 as a 1, the 2, 2 as a 2, the 3, 3 as a 3, and it's describing seeing the 1, 1, 2, 3 as being 1, 2, 3, the 1, 2, 2, 3, 4 as 1, 2, 3, 4, and so forth. Something else is an extremely common phenomenon in human cognition. People routinely understand each other despite speech errors. In mathematics, integration is seen as being just an extreme case of summation. Linear transformations are seen as matrix multiplications and so forth. Seqsee has only a limited ability of seeing something as something else, but it was a fun challenge trying to get it to that stage. This then was a sampler of the richness of the domain. I have not had chance yet to talk about how Seqsee actually does what it does, or how well it does it, and so forth, but subsequent videos in this series should talk about that. Thanks for listening.